Hello everyone, welcome to Diksha. So today's video is going to be a continuation of last video. We are going to discuss the next 25 questions from physics of NEET 2023 examination. Alright, so my name is Sandesh and let's begin. So the first question from this section is going to be on hydrogen spectrum, so Bohr's theory. Alright, so let's look at the question. Let's read the question. It says, in hydrogen spectrum, the shortest wavelength in Balmer series is going to be lambda. Then find out the shortest wavelength in bracket series. Okay, so Balmer series and bracket series. Let's talk about these two first, and then next we'll talk about shortest wavelength, what does it mean, so on. Okay, first of all, you must all remember the sequence: Lyman, Balmer, Paschen, bracket, and P-friend. Okay, so it starts with Lyman, and that's when your electron ends up in the first orbit. And then there is Balmer, in which your electron ends up from nth orbit to second orbit. Then there is Paschen. Paschen is n to 3, and then bracket. Bracket is n to 4. Okay, all right, good. So we know this now. But what about these n values? How do we find out these n values? And that's where shortest wavelength concept comes into picture. Shortest wavelength for a series is the one that has the most energy. Remember the formula of EM waves, E is hc by lambda. So the one that has the least wavelength has the most energy. And what's the most energy gap you can have between a Balmer series? The most can be from infinity to 2. So from outside to the second orbit. Similarly, for bracket series also, the shortest wavelength or the most energy can be from infinity to 4. Okay, so these are the two energy levels we are dealing with right now, infinity to 2 and infinity to 4. So let's compare their wavelengths. Wavelength, if you remember, has a formula of 1 by lambda is r 1 by n1 square minus n2 square minus 1 by n1 square, where n2 is this and n1 is this. Okay, so if I were just to talk about the ratios of wavelengths of Balmer and bracket, it would look something like this. Lambda 2 by lambda 1 will be r by r 1 by 2 square minus 1 by infinity square divided by 1 by 4 square minus 1 by infinity. 1 by infinity or 1 by infinity square is 0, and this r cancels out, so this is 1 by 4 into 16 by 1. In other words, 4. So lambda 2 by lambda 1 is how much? 4. So lambda 2 is 4 lambda. And that's your answer. Okay, let's move on. Alright, next question. Next question says, work function of cesium, potassium, sodium is given as 2.14, 2.3 and 2.75 electron volt. If incident electromagnetic radiation has an incident energy of 2.2 electron volt, then find out which of the following surfaces may emit photoelectrons. So understand one thing first: sodium, cesium and potassium, all three are already photosensitive elements. They can produce photoelectric effect. The only obstacle is the energy of incident light. And what's the constraint here? What's the requirement? This energy has to exceed work function of that material. Remember what's the definition of work function is. Work function is the minimum energy required by the incident light such that the electrons can leave the metal surface and come out of the metal surface. Okay, so if you're not giving that much energy, you cannot have photoelectric effect. So for example, in case of sodium and potassium, the energies are already more than the incident energy, so there will be no electron, there will be no photoelectric effect. Only 2.14, which is less than 2.2, which is of cesium, will have a photoelectric effect. So option number 1, cesium only, should be the correct answer. Alright, let's move on to the next one. This one was easy. This one's even easier. Let's see this. The error in measurement which arises due to unpredictable fluctuations in temperature and voltage are. So the first thing we need to understand is the reason why this error is happening. And they have given us the reason being unpredictable fluctuations. It's unpredictable. We cannot predict it. So what kind of things are those which we call unpredictable? Things that are random. So these kind of errors are categorized as random errors, and anything unpredictable as such will be categorized in random errors. Since we are here, let's just talk about all the other three as well, just to have a revision of sorts. Instrumental errors. These are the errors that can happen because of faulty instruments. Instrument being wrong, instrument having wrong measurement scales, or instrument having wrong equipment or device. Next, personal errors. These happen when the person making the observation makes the mistake. Okay, so maybe it said 2 on the scale, but you noted down 4. That's a personal error. Least count error, that happens when the scale of the instrument is misaligned, not necessarily wrong, but just a little misaligned. That is called as least count error. And then there are the fourth type, which are completely unpredictable. Those are called as random errors. Let's move on. So the next question, there is a series LCR circuit. L is given as 10 millihenry. Capacitance C is given as 1 microfarad. And resistance R is given as 100 ohm. They're asking you to find out frequency F where resonance is happening. Okay. Do you remember the formula? Angular frequency of resonance, omega, is given by root of LC. Correct. And omega is also 2 pi f. So 2 pi f is equal to 1 by root LC. You want this f right now. So this f will simply be 1 by 2 pi root LC. So let's do this calculation. 1 by 2 into pi is 3.14 approximately, into root of 10 millihenry. So I'll write 10, I'll write minus 3 for milli, into capacitance is 1 microfarad, so 1, and I'll write minus 6 for micro. Okay, minus 6, minus 3, minus 9, minus 8, minus 4 outside. So this will become 2 into 3.14 into 10 to the power minus 4. In other words, this will just become 10 to the power 4 by 2 into 3.14. That's 10 to the power 4 can be written as, if I just look at the options now, I can just write it as 10 by 10 to the power 3 divided by 2 into 3.14, and that's 5 by 3. 5 by 3 is 1.5, close to 1.5, 1.6. So this is 1.6 into 10 to the power 3, which if I just check, 1.6 kilohertz, option D, that should be the answer, somewhere around that. Okay, let's move on. Venturi meter. Now Venturi meter works on the principle of Bernoulli's principle. This isn't even close. These two aren't even from the same chapter. These are from rotation. These principles are from rotation. This is a fluid mechanics question. Huygens principle, Bernoulli's principle. Huygens principle is from wave. This isn't even about it. Venturi meter, by the way, if you don't know, measures the differences of pressure using the differences in speed. Okay, so definitely does not work on the principle of anything else other than Bernoulli's principle. Moving on to the next question. The ratio of frequencies of fundamental harmonics produced by an open pipe to that of a closed pipe having same length. So if you are having confusion, remembering that there are two formulas of frequencies, f by v by 2l and v by 4l. Which one is open, which one is closed? If you are having confusion remembering this, I have a simple logic for you. Okay, this is a closed pipe and this is an open pipe of same length. Okay, now the closed pipe, when it produces the first harmonic, this is how the wave looks like. The standing wave we're talking about looks something like this. Okay, and the open pipe, when it produces that same thing, the first wave looks something like this, right? Out of these two, which one has the biggest wavelength? Closed pipe, right? That's only 1/4 of the wave, while this is 1/2 of the wave being covered here. So closed pipe has more wavelength. So closed pipe should have smaller frequency, more wavelength, smaller frequency. Open pipe has less wavelength, so it should have more frequency. Okay, not confusing at all as long as you remember this. So open to close, v by 2l by v by 4l, which is VL cancels out, 4 by 2, or 2 should be the answer. 2, option number 2. Moving on. Alright, next question from electrostatics. It's a question about dipole, and the question says electric dipole is placed at an angle 30 degree with an electric field. Okay. Electric field's value is given, this value, basically E is given, 2 into 10 to the power 5 Newton per coulomb. It says it experiences a torque of around 4 Newton meter. Alright, so value of torque is also given. Calculate the magnitude of charge on the dipole. So this is torque. Magnitude of charge just means they are asking you to calculate Q if the length of the dipole L is 2 centimeter. Okay, so what is the formula of torque on a dipole? The magnitude of torque on a dipole is magnitude of P cross E, or it is P E sine theta. Okay, theta being this angle 30 degree. So let's write all the things we know right now. Torque is known, 4 Newton meter. P can be known. P is Q into L. Right? Dipole moment of a dipole is the charge on the dipole and the length of the dipole into value of magnetic field, electric field E, and value of sine theta, whatever it is. So let's write all the values. Charge on the dipole is not known, so let's write it as Q. Length of the dipole is 2 centimeters, so let's write it as 2 into 10 to the power minus 2 for centimeters, into E is given as 2 into 10 to the power 5, so let's write it as 2 into 10 to the power 5. Sine theta, sine 30, let's just write quickly, sine 30 is 1 by 2. So this will cancel out, these will cancel and become 10 to the power 3. So the answer comes out to be 4 is equal to Q into 2 into 10 to the power 3, or Q becomes 4 by 2 into 10 to the power minus 3, which is just 2 into 10 to the power minus 3 coulomb. So 2 microcoulomb should be the answer. Get it? Okay. Let's move on. A simple question from current electricity, should not be very difficult. Let's see. Magnitude and direction of the current in the following circuit is. Let's observe the circuit. The circuit has two batteries, one 10 volt and one 5 volt. Understand that these two batteries are acting in the opposite sense to each other, so they're cancelling each other out. Okay. So if I were to draw a net resultant of these two batteries, it would look something like this. Okay. In the direction, in the sense of the bigger value, and a resultant of these two, 10 minus 5, which is 5 volt. So a 5 volt battery effectively is connected to this circuit right now. What is the R equivalent of this circuit? We have three resistances, 1, 2 and 7. Together their equivalent is going to be 1 plus 7 plus 2, 10 ohm. So if I were to just talk about the current here, current will simply be V by R, which is 5 by 10, which is half ampere. So a current of half ampere will go from where to where? From the positive plate of the battery to negative plate, like this. So it will go like this. So 0.5 ampere from A to B through E. So this should be the correct answer. Option number 2 should be the correct answer of this question. Alright? Okay. Next question. The net magnetic flux through any closed surface is. So now this is a question of Gauss's law in magnetic field. Okay. What does Gauss's law in general say? Gauss's law says flux passing through an closed surface, magnetic flux that is going to be 0. So the answer to this question is 0. This could not have been easier. If you are still confused about this, I suggest just go and pick up the book, find out Gauss's law in magnetism, and you will find that the statement of the law is net magnetic flux through any closed surface is 0. Okay, so see look at the amount of question, the difficulty of the question that is being asked. It's a simple theoretical question. All right, let's move on to the next one. All right, let's look at this question. Now a question from 11th standard. Let's see what it says. A bullet is fired from a gun at an initial speed of 280 meter per second. All right. The angle which it makes with the horizontal is 30 degree. Okay. That's the projection angle then. That's what that means. Find out the maximum height attained by the bullet. Basically, it's being launched like this. It'll go like this and land back like this. We want to calculate this maximum height. Okay, so this is a straightforward projectile motion question. U is given, theta is given. What is the value of h max? H max is u square sine square theta by 2g. So let's put all the values here. Let's see what the calculation comes out to be. 280 square into sine square theta. So 1 by 2 into 1 by 2 divided by 2g. So 2 into 9.8. That's what they asked us to take. So that's what we are going to take. Okay. All right. So as you know, 9.8 can be written as 2 into 4.9, because that's when this the whole thing can be divisible by 7. So let's use that 7th divisibility. This becomes 140 and this again becomes 70. Moving on, we can again reduce this to 35. Okay, you can use this 2 here to make this 140, and now let's divide by 7, make this 5, and let's divide by 7 again, make this 200. So what we are left with essentially is 200 and a 5. So 5 2s are 100. So 5 2s are 10, that's 2 zeros, 1000. 1000 should be the answer. There you go. A little complicated in terms of calculations, but nothing you couldn't do in the exam on your own, alright? It's easy. So option number 3, 1000 meters should be the correct answer for this question. Alright, let's move on. Next question is from ray optics. The question says, two thin lenses of same focal length f, but one is convex lens and another one is a concave lens. When they are placed in contact with each other, the equivalent focal length of the combination will be. So basically, a concave lens like this and a convex lens like this and a concave lens like this both have equal focal lengths, just in value, not in the plus and minus, but the values are equal. So when you keep them in contact with each other, what is the equivalent focal length of them? That's the question. Now you know equivalent focal length is 1 by f1 plus 1 by f2. The only problem is these values f and f are not exactly same sign. Okay, convex lens has positive focal length and concave lens has negative focal length. So when you do this, this just becomes 1 by f minus 1 by f because of the negative sign, and the whole thing becomes 0. So 1 by f equivalent becomes 0. In other words, f equivalent then becomes how much? Infinity. So yep, infinite. That should be the answer. Okay, let's move on to the next one. So this question is from AC again. Net impedance of the circuit as shown in the figure will be. You have a inductor, you have a capacitor, and you have a resistance connected to a supply like this, and they are asking you to calculate net impedance Z of the circuit. How do you calculate Z? Z is given as root of XC minus XL or XL minus XC, doesn't matter because we are squaring it anyways, plus R square whole root. Okay, so what do you need then? You need XC, you need XL. How do you calculate XC? XC is given by 1 by omega C, and XL is given by omega L. We don't know omega right now. What is the angular frequency of the circuit? We don't know, but that can be found out because we know the frequency of the circuit f, and that is given as 50 Hertz. So omega will simply just be 2 pi f. Okay, so we'll write it as XC, we'll write it as 1 by 2 pi fc, and then we'll calculate this 2 into pi into 50, because that's what frequency is, into C, capacitance. That's 10 to the power 3 by pi into micro, so 10 to the power minus 6. And let's do this calculation. Cancels out, and we are left with 100 into 10 to the power minus 6. 100 into 10 to the power 3, which is 10 to the power 5 into 10 to the power minus 6. So that's 1 10 to the power minus 1, or that's just 10 ohms. Okay, so that's that, 10 ohms. Moving on, XL is omega L, or in this case it should be 2 pi FL. So let's write all the values here. 2 into pi into frequency is 50, inductor's value is given as 50 by pi, into millihenry. So let's write it as 10 to the power minus 3 for the milli. Okay, all right, so cancel this pi out from here, that's 100 again, and that's 100, 10 to the power minus 3 becomes 10 power minus 1, so the whole thing becomes 5 ohms. Okay, just do the calculations on your own, okay, don't trust me. So you have this as your XC and you have this as your XL. So what is left then? All you need to do is to calculate this now. Everything else is known. Value of R, 10. Let's put all the values here. Let's calculate Z over here, alright. Root of this minus this, 10 minus 5, that's 5 square, plus R is 10, so 10 square. 25, 100. Root of 125 is what I'm looking at. Or I can just write this as root of 5 into 25. This comes out of the root and becomes 5 root 5, which should be the answer for this question. Option number 3. Okay. All right. Let's move on to the next one. So a question from simple harmonic motion then. The question says xt graph of a particle is given. You can see it from the graph. They don't have to tell you that this particle is performing a simple harmonic motion. Just by looking at the sine curve, you can tell me that this motion right now that you see is going to be a simple harmonic motion, right? So anyways, it is a simple harmonic motion. They are asking you to calculate acceleration of this particle at a certain amount of time. Time is equal to t is equal to 2 seconds. All right, okay. So how do we do this then? First of all, let's write down the equation x is equal to f of t for this simple harmonic motion, okay? What should be this value of x in terms of time? Once we get this, we'll differentiate it once, get the value of velocity, differentiate it again one more time, get the value of acceleration, then put the value of time, get our answer, okay? Chalo, let's find out x is equal to f of t. This is going to be a sine function, so x is going to be some kind of a sine omega t, and all I will need to do right now is to calculate this omega. How do you calculate omega? Omega, as you know, is 2 pi by time period. We know this formula. 2 pi divided by what is the time period of this wave? In how much time does this wave complete a full cycle? That's right, 8 seconds. So 2 pi by 8 or pi by 4. Okay. So x just becomes sine omega, which is pi by 4 into t. What is the amplitude of the wave? Amplitude of the wave is 1, so 1 sine omega t. Okay, so sine pi by 4 t. Let's differentiate this once. Let's get the value of v dx by dt, which is going to be pi by 4 cos pi by 4 t. Correct? Sine theta's differentiation is cos theta, and the inside once it comes out like this. Let's differentiate this again. Let's do dv by dt, which will be the acceleration now. Minus pi by 4 square sine pi by 4 t. This happens because cos theta's differentiation is minus sine theta, so the minus sign carries over, and that's what I get. So let's put the value of t is equal to 2 here. What happens when I put t is equal to 2 here? I get acceleration at t is equal to 2 to be minus pi by 4 square into sine pi by 4 into 2, which is pi by 2. Sine pi by 2, as you remember, sine 90 degree should be 1. So the answer that remains here then is minus pi square by 16. Minus pi square by 16, or option number 4 should be the correct answer for this question. Okay? Okay. Let's move on. Let's look at this question from electrostatics again. The question says, there's an electric dipole and it is placed in space as shown in the figure. Okay? They are asking you to calculate electrostatics potential of this setup at point P. Okay. So how do we calculate electrostatic potential due to a dipole? Do we have a formula for that? Some of you might remember the formula for that, Kp by r square or something like that. That's not required. Alright. we're not going to treat this dipole as a dipole now. What we are going to do is, we're just going to treat this dipole as a charge. Two charges actually. This one and this one. So this one will have some potential here. We'll find that value. And then this one will have some potential here. We'll find that value. Total potential due to the setup will just be simply addition of potentials. Why? Because potential is a scalar quantity and you can just add it like numbers. Okay. So let's do that. Let's write it as K plus Q by, what's this distance? 5 minus 3, 2, right? This distance, 2. So let's write it as 2 centimeters plus K minus Q by, what's this distance now? 5 plus 3, or 5 plus 3 is 8. So let's just write it as 8 centimeters. Okay. Let's take everything that can be taken common out of this. K can be taken common, Q can be taken common, 10 to the power minus 2 also can be taken common, and I am left with 1 by 2 minus 1 by 8. 1 by 2 minus 1 by 8. So that can be calculated now. That's just 16 into 6, like that, into 9 into 10 to the power 9 into value of Q is given, right? No, not required actually. Value of K is also not required. 3 by 8 into QK, and that should be the answer. I guess they're not asking you to convert things into centimeters. 3 by 8 into QK should be the answer for this question. All right. Okay. Let's move on. Let's look at the question. It says a bullet is fired from a gun on a rectangular wooden block with velocity u. Basically what's happening is, there's a rectangular block here. There's a bullet coming towards the rectangular block with speed u. The bullet first travels 24 centimeters through the block like this, along its length horizontally, and at this point the velocity becomes u by 3. Then it further penetrates the box in the same direction before coming to rest exactly at the other end. Basically comes to the end here. Then find out the total length of the block. Okay, that's the question then. Bullet comes in, covers u by 3 distance, covers some distance and comes to speed u by 3, then covers more distance and completely stops. This distance, by the way, is given as 24. So if you can just find out this distance, basically you know the total length of the block, right? So first let's start here. Let's use this distance 24 to calculate acceleration or deceleration of the bullet from here to here. Okay, how do we do that? Well, we'll use the third equation. We'll first write down the things that we know. Bullet's final velocity here is going to be u by 3. Initial velocity was u and the distance traveled was 24. Okay, so let's calculate a from here. Third equation says v square minus u square by 2s should be the value of a, or in this case it should be u square by 9 minus u square by 2 into 24. Now this value is not going to change, right? Understand, acceleration or deceleration in this case is going to be same throughout the block that we are going here. So this value is going to be now minus 8 by 9 u square by 2 into 24. So I can just write this as 3, 9, 2, 3, that's 18 into 3, 54 minus u square by 54 as my acceleration. Now I'm going to use this acceleration value in this part of the journey because it's going to be same, and find out whatever is required, the distance. Okay, so how do I find out this distance now? Well, for this part of the journey, initial speed is u by 3. Notice, I start here, initial speed is u by 3, final speed, I stop here, so final speed is 0. Acceleration again going to be same, so u square by 54, and then for this I need to calculate time, the distance. So how do I do that? Again, third equation, v square minus u square by 2a. So that's going to be 0 minus u square by 9 divided by 2 into minus u square by 54. Minus u square cancels out, and I get 54 by 2 into 9. That's what I get. So 3 is the answer. So basically what I'm saying is this length is 3 meter. So the whole thing is 24 plus 3 or 27 centimeters. Okay, understood what we did here? First analyze the motion from here to here using third equation of motion, and then find out the value of acceleration and use that value of acceleration on the second part to find out the distance, and that comes out to be 3. So the total length of the block comes out to be 27 centimeters. Okay, so that should be the answer. Let's move on to the next question. A question from ray optics. It talks about combination of lenses. Let's see what the question says. In the figure shown, find out the equivalent focal length of combination of these 3 lenses. What 3 lenses? 1, 2, 3. Understood? Now, to calculate equivalent focal length of these kind of lenses, we first need to find out their individual focal lengths. So let's call this f1, let's call this f2 and f3. We need to first find these out and then add them. How do we add them? 1 by f equivalent, if you remember, when lenses are in contact, is 1 by f1 plus 1 by f2 plus 1 by f3, and that's right. So when you have something like this, you individually calculate their focal lengths using lens maker's equation, and then 1 by f1 plus 1 by f2 plus 1 by f3 will give you the value of equivalent focal length. We are in luck here. f1 and f3 are essentially just same lenses, same shape, same size, same curvature, just one is flipped in the other side. Okay, just because you flipped a lens doesn't mean its focal length changes, right? It's still the same lens. So f1 and f3 is going to be same. f1 and f3 is going to be same. All I need to do now is to calculate f1 and f2, and I will have my answer. So let's start with that. Let's start with calculating f1. 1 by f1 will be mu minus 1 by r1 minus 1 by r2. This, if you don't remember, is called as lens maker's equation. So let's find out what r1 here is, let's find out what r2 here is. Okay, for this lens of shape like this is the first curvature r1, and you can clearly see it's infinity because it's a flat surface. This one has its radius of curvature lying on this side, so this is a positive value, plus, and how much plus? 20. So plus 20. Okay, so let's put the values here and let's find out what the 1 by f is. 1 by f will be 1.6 minus 1, 0.6 into 1 by infinity minus 1 by 20. Okay, I've just put the values here, and this becomes minus 0.6 by 20 as my 1 by f1. I'm not going to solve it any further. I'll just keep it as it is. Okay, there's no need to calculate f1 exactly because I need 1 by f1 value immediately later on. So let's keep it like this. Let's move on to the second lens. Let's move on to this convex lens. For this lens, as you can see, this value is positive. So r1 I will write it as plus 20, but you can clearly see this value is in this direction, right? The center of curvature for this curve is going to be here in this direction, in the opposite direction of this. So this will be, r2 will be minus 20. Okay, so when I write 1 by f2, I'll write it as 1.5 minus 1 or 0.5 into 1 by 20 minus 1 by minus 20. 1 by 20 minus 1 by 20, that's 1 by 20 plus 1 by 20 or 1 by 10. So the whole thing becomes 0.5 by 10. Again, not going to touch it, just keep it like this. 1 by f1 is minus 0.6 by 20, 1 by f2 is 0.5 by 10. So let's use this formula here now. 1 by f equivalent becomes 1 by f1 plus 1 by f2 plus 1 by f1 only. 2 by f1 plus 1 by f2, or 2 into minus 0.6 by 20 plus 0.5 by 10. Get it? 2 into minus 0.6, 1.2 by 20 minus 1.2 by 20 plus 1 by 20, let's write it as, okay, 1 by 20. So 1 minus 1.2, in other words, minus 0.2 by 20. So minus 0.2 by 20 or minus 0.1 by 10 is my 1 by f equivalent. So if I just calculate f, then it becomes 10 by 0.1 with a minus sign or 100 with a minus sign. That should be the answer then, minus 100. And that's option number 3. That should be the correct answer for this question, okay? It looks complicated, might feel like it's complicated, but it's really not. The only formula we are using here, apart from this one, which is a known one, is Lensmaker's equation, okay? As long as you understand how to use Lensmaker's equation properly, with its sign conventions, with all the possible cases, there is nothing that you can't achieve in this question, okay? All right. So what's the answer then? Answer is option number 3. Let's move on. Let's look at this question from semiconductors. I told you in the last video, pay very close attention to logic circuit type of questions in NEET, because these questions are very frequent. Every year we get at least a few of them. So this year we have gotten this one. This is a combination of a NOT gate, 2 NOT gates, and a NAND gate. Okay. So as you know, NOT gate, what does it do? It just flips the value. Whatever value you feed it, it just flips it. If you feed it 0, it gives you 1. If you feed it 1, it gives you 0. And then NAND gate. NAND gate first does the AND operation, which is product, and then it flips the product, okay? So if you feed it 1 and 1, for example, it first does the AND operation, which is 1 into 1, that's 1, and then flips it. So 1 into 1 is 1 into the opposite of that is 0, so it outputs 0, okay? So you understood what each logic gate does. This one simply flips the value. This one takes whatever you feed it, flips it, first produces, multiplies it, and then flips it, okay? All right. So let's start and making a truth table, okay? Let's first feed 0 and 0 values here. Good? Then NOT gate will flip it, make it 1, 1. NAND gate now will first multiply them. 2, 1 into 1 is 1, and then flip it. So make it 0. Understood? 0, 0, 1, 1, 1 into 1 is 1, flip it, 0. So let's go to 0 and 1. Let's make it 0 and 1. 0 to 1, 1 to 0 because of the NOT gates. And then NAND gate multiplies them. Multiplication is 0, flips it, which is 1. Same 1, 0 also will have 1. Let's go to 1 and 1. Let's make these two 1 and 1. Now if this is 1, this becomes 0. This is 1, this becomes 0. 0 into 0 is 0. Flip that, that's 1. So let's check where this table lies. 0, 0, 0, 0, 1, 1, 1, 0, 1, and 1, 1, 1. That's option number 2. That's the answer. Okay, not very complicated. As long as you remember what NOT gate does, what NAND gate does, it's not very difficult. Let's move on to the next one. Let's look at this question. The question says, a horizontal bridge is built across a river. A student standing on the bridge throws a small ball vertically upward with a velocity of 4 meters per second. So basically, this is a bridge, this is a water. Some student is throwing a ball vertically upward with 4 meters per second like this. This ball is going up, coming back down into the water, okay? The time taken to do this whole thing is 4 seconds. Then find out the height of the bridge above the water surface, okay? How do you do this? Let's write the equation. S is equal to ut plus half at square. Along with sign conventions, okay? Let's pay attention to the sign conventions. Where am I going? What is my displacement? My displacement is in this direction. That's my S, and that's negative. So I'll write it as minus h is equal to. Where is my u? Where am I launching the object? Upwards. So plus 4 into 4 plus half. Where is my acceleration? Upwards? No, right? Downwards. So minus 10. Time 4 square. Okay. So let's do this calculation. Minus h becomes 4 into 4, that's 16, minus 10 into 8 minus 80. Isn't it? 4 into 4, 16, 10, 8, 80. 80 minus 16 is around 64, but with a minus sign. So that's okay, the minus minus cancels out, height comes out to be 64, and that's my answer. That's option number 3. Not very complicated at all, right? Yes, as long as you do the sign conventions properly, this is not a complicated question by any means. All right, let's move on. Let's go to the next one. Okay, next question I think is from current electricity. I can see the resistors here. 10 resistors, each of resistance R, are connected in series. They're connected in series to a battery, EMF E, and no internal resistance. Then these same are connected parallel to the same battery, and the current in both the scenario has increased by n times. So first they were connected in series like this to some battery E. Let's call this current to be I series, and then they were connected parallel like this, same battery. Let's call this current now current in parallel. They're saying that this current is n times this current. IP is said to be n times I series. So they are asking us to calculate this n. Okay, all right. So how do you do this? Let's write down the value of series current. Series current will be EMF of the battery divided by total resistance. Okay, if you have R, 10 of these connected in series like this, what is the equivalent resistance? Absolutely, it should be 10 times the value, right? R plus R plus R 10 times. Okay, so E by 10R. Let's calculate IP. IP will be E by R equivalent again. R equivalent in parallel, what is it? R. N of these are connected in series, in parallel. Then equivalent becomes R by 10. Okay, remember this. In series, it's N times R. In parallel, it is R by N. Okay, so it becomes 10 E by R. Okay, so E by 10R, 10 E by R. Let's find out this N value. This N value is nothing but IP by IS. So it is nothing but 10 E by R divided by E by 10R. Correct? E by R cancels out. 10 into 10 is the answer, or 100 is the answer. Get it? 100. Option number 2 should be the correct answer for this question. How simple? As long as you remember the formula, equivalent in series it is n times the each resistance, and equivalent in parallel is 1 by n times the each resistance. Okay, let's move on to the next question. Question says a wire carrying current I along positive x-axis. Okay, so the wire is carrying a current along positive x-axis and has length. It is kept in magnetic field. Field B is given as 2 I cap plus 3 j cap minus 4 k cap. Okay, some vector value. Find out the value of magnetic force. Value of magnetic force when current, length and magnetic field is given. What is that? That is, the formula of force is I L cross B, isn't it? Okay, so force will be current into L, length is L, in what direction? In positive x direction. So I cap cross B, which is given as 2 I cap plus 3 j cap minus 4 k cap. So as long as I can do the cross product, my answer should be right there. L into 2, that's 2L. I cross I, that's 0. Cross product of I, cross product of J, cross product of any two parallel vectors, 0. So nothing here, plus I cross J, K, 3L K cap. Then I cross K, that's minus J with a minus sign, that becomes plus 4L. Sorry, 4L, IK is J, so I'll write it as J cap. 3L K cap, 4L J cap. I can take L out of this, IL, 3K cap plus 4J cap. If somebody asks you, calculate the magnitude of this force, magnitude, you will just say it should be IL root of 3 square plus 4 square, or 5IL. 5IL. Option number 3 should be the correct answer for this question. Get it? Alright, let's move on to the next one. Okay, a question from gravitation then. A satellite is orbiting just above the surface of Earth. This is an important information, just above the surface. With time period t. If d is the density of Earth, g is the gravitational constant, then what is this quantity? How does it relate to time period? Okay. So first of all, time period of any satellite in general is equal to speed of the satellite divided by distance covered by the satellite by speed, right? Time is distance by speed. What distance are we talking about? The distance of full circle orbit. That distance divided by the orbital speed. So how much distance does a satellite cover when it's very close to Earth? This is Earth of radius r, satellite's right over here. What distance is it covering? 2 pi r. And with what speed? Orbital speed. If you remember, orbital speed for a satellite very close to Earth or anything very close to Earth is root gm by r itself. Okay. So use that formula here. Time period comes out to be 2 pi r by root of gm by r. In other words, this just becomes 2 pi r cube under root gm. All I've done is squared this with an under root like this and then flipped everything and collected it all together. So the time period formula comes out to be 2 pi root r cube by gm. Okay. Now what do? Somehow try to introduce density into the mix. Okay, let's try to introduce density into the mix. How we will do it? By using mass. Mass is going to be volume into density. So I'll just write this as d into, since Earth is a sphere, 4 by 3 pi r cube is the volume of Earth, and that is what I'll write here. Okay. So from here, time period comes out to be 2 pi root of r cube by g into 4 by 3 pi r cube into d. Okay. R cube cancels out, and what I'm left with is 3 by 4 g pi d under root into 2 pi. Now what I'm going to do is take this 2 pi into the square root, and this becomes 3 into 4 pi square by 4 pi g into d, and I'm left with root of 3 pi gd is equal to time, right? Root of 3 pi gd is equal to time. This is what I get. Time is equal to root of 3 pi by gd. Basically t square is what the value is. Understood? So that's the answer, option number B. Alright, moving on. Calculate the maximum acceleration of a moving car so that a body lying on the floor of the car remains stationary. The surface of the car, of course, has a coefficient of friction of 0.15. Why did I say of course? Because otherwise, if you move a car, anything that is inside the car will just, slide off if there was no friction. So you understand that as long as there is a relative motion, as long as there is no relative motion between the surface of the car and the object on it, there has to be friction on it. Okay. So let's say this is the surface of the car. Let's say this is the object. If you accelerate a car like this, what happens is this one needs some kind of a friction in between to keep holding on to the car surface. Okay. How much friction? We can calculate that. All right. It's the same thing as applying force here and getting balanced. Okay. If you move something on the floor or move the car from beneath the car floor from beneath the object, it's basically the same thing as far as friction is concerned. Okay. So to keep a contact here, to make sure that this doesn't move, you need to make sure that the static friction value, the maximum value, mu mg, is not exceeded. So the force that you are applying, ma, should not exceed this force. This ma force should not exceed this force. Alright. So they should be equal at the minimum. So the value of acceleration then comes out to be nu times g, which is going to be 0.15 times 10 or 1.5 meter per second square. That's your answer. Simple enough. Understood? All right. Let's move on to the next one. Resistance of a platinum wire at 0 degrees Celsius is 2 and 80 degrees Celsius is 6.8. Then find out the temperature coefficient of resistance, sometimes also called as alpha. So what is the formula here then? Resistance at a temperature T is resistance at 0, 1 plus alpha delta T. You all remember this formula, right? To calculate resistance at any temperature. Okay. So let's put the values here. Resistance at 80 degrees Celsius is 6.8 is equal to 2 in the bracket 1 plus alpha delta T, which is 80 here. So 6.8 by 2, that just becomes 3.4 is equal to 1 plus alpha into 80. So 2.4 becomes 80 alpha, and from here alpha becomes 2.4 by 80. I'm just going to write it as 24 by 800, so that this becomes 3 into 10 to the power minus 2. 3 into 10 to the power minus 2 per degree Celsius, or option number 3 should be the correct answer for this question. Alright? Make sure you do these calculations correctly. Make sure you remember the formulas also correctly. Alright? Option number 3 should be the correct answer for this question. Let's move on. So, the penultimate question of this saga now. The radius of innermost orbit of hydrogen is this. Then what is the radius of third allowed orbit of hydrogen? Radius of hydrogen has a formula of 0.53 angstrom for the first orbit, 0.53 angstrom, or that's what the value is, 5.3 into 10 to the power minus 11. And subsequent radiuses can be given with this formula, 0.53 into n square by z. So any hydrogen-like atom, any orbit, that's the orbit number and that's the atomic number. For hydrogen itself, for hydrogen, z is 1, so the value will be 0.53 into n square. In our case, third allowed orbit is 3, so 0.53 into 3 square, which is 9, so 0.53 into 9. Now, I'm going to do a rough calculation here. 9 into 5 is 45. 9 into 5 is 45, so 0.45 or something like that, 4.5 angstrom or something like that is what I'm expecting. So roughly that's around option number 4. All right. I'm not asked the exact value, and the answers also are very different. So as long as you are roughly there, it's okay. All right. Option number 4 should be the correct answer for the question. Let's move on. All right. So the last question and the longest one. Let's pay very close attention to what we are going to do here. Okay. A very long conducting wire is bent into a semicircular shape to form this shape. All right. The magnetic field at point P, so this is the point P, for a steady current will be. Okay. So what's basically happening is, wire comes in like this, curves around, goes back. What is the value of magnetic field here due to this whole thing that we have made up here? Let's break this apart in 3 segments. Segment number 1, a semi-long infinite wire. Semi-infinite wire. Segment B, this, a semicircular wire. And segment C, another semi-long wire, okay, or semi-infinite wire. So let's talk formula. First of all, let's talk the first formula. What is the value of magnetic field due to a current carrying wire infinitely long at a point D from it? You must remember this value. B is nu naught I by 2 pi d. Okay. Now if it's an infinite wire from both ends, what if it's a semi-infinite wire? If only one portion of it is there and the other portion is not there, then half of that, right? Nu naught I by 4 pi d. You remember this formula? Let's write it in the corner somewhere. For semi-infinite wire, B for semi-infinite is nu naught I by 4 pi d. Okay. All right. Next talk about an infinite wire. Okay. Next, let's talk about circle. At the center of a circle, what is the value of magnetic field due to a current I? Nu naught I by 2a if the radius of the circle is a. or 2d if this radius is d. Okay. Now what if it's a half circle? What if it's a half circle? B will be mu naught I by 4d. Okay. Let's write that value here as well. B of semi-infinite wire, we wrote it as mu naught I by 4 pi d, and B of a semicircle will be mu naught I by 4d. Correct. Let's remember these two values as we go on and calculate these magnetic fields. Okay. First of all, let's use right hand thumb rule to calculate the direction of magnetic field due to this wire, segment AB, down. Let's use same thing to calculate magnetic field here. This one will have up. So this one down, this one up, and what about this one? Down. So these two will add up and this will subtract from them. So nu naught I by this distance 4 pi r plus mu naught I by 4 pi r minus this one is upward, so that will be subtracted, mu naught I by 4r plus minus. In what direction? In this direction. Yes, absolutely right. So this will be nu naught I by 2 pi r minus nu naught I by 4r in this direction. Okay. So if I just take nu naught by 4r common, nu naught by 4r is taken as common, then this whole thing becomes nu naught by 4r. This whole thing becomes common. 1 by 2 by pi minus 1 pointed away from the page. This should be my answer. Okay. Mine is this. This should be, the opposite of that should be in this direction. Alright, not a problem. Option number 3 is the one I'll choose as the correct answer for the question. Okay. Why not into the page, sir? You just marked into here. Yes, but that was I by 2 pi r minus I by r. They are giving me I by r minus I by 2 pi r wala answer, so I'll flip my direction. Get it? If not, do this for yourself, check this out, see if you get it correct. Alright, so that brings us to the end then. That's all the questions we had from NEET 2023 examination. I hope you found all of these questions very easy. If not, that just goes to tell you which chapters are weak, which ones you need to prepare more, which ones you are maybe forgetting the formula for. Stay tuned to the channel and we will be covering more of those chapters later on. Till then, see you guys. Bye bye.